Module Technical Course Internet of Things for Industry 4.0, Lecture 3, Embedded Systems at the Basis of IoT Infrastructure. During this lecture, we will discuss why embedded systems are the basis of the IoT infrastructure, what types of embedded system exists, and how to implement them using modern hardware-software platforms, sensors, and actuators. Like the author of this citation, we will take the following definition of IoT as a basis. The Internet of Things is the interconnection of uniquely identifiable embedded computing devices within the existing Internet infrastructure. So, Internet of Things is, in fact, the connection of the embedded systems to the Internet. The following diagrams explain what the IoT is. The Internet of Things is an architecture that includes specialized hardware boards, software systems, web application programming interfaces, protocols that together create a seamless environment. It allows smart embedded devices to be connected to the Internet so that sensors data can be accessed and control system can be started over Internet. Devices can be connected to the Internet using various means. Furthermore, devices may not need an independent Internet connection. Instead, a cluster of devices, for example, a sensor network, can be created and the base station or a cluster head can be connected to the Internet. This leads to more abstract architecture for communication protocols that range from high to low level. Embedded systems can be classified into two broad categories. The first is based on performance and functional requirements and is divided into the following four groups. Standalone embedded devices, for example, microwave oven, washing machine. Embedded real-time systems, for example, control systems for unmanned moving objects. Networked embedded systems, for example, a home security subsystem. And mobile embedded systems, such as smartphones, digital cameras, etc. Another category of embedded system is based on microcontroller performance and is divided into three categories. Small-scale embedded systems, designed with a single 8-bit or 16-bit microcontroller. Medium-scale embedded system, usually designed with one or more 16-bit or 32-bit microcontrollers or digital signal processors. And sophisticated embedded systems. They may require scalable or configurable processor and programmable logic arrays. The main steps of the traditional embedded system design process allow to determine the requirements, design the system architecture, select the operating system, select processor and peripherals, choose a development platform, code applications and optimize them, verify the software on the host system, and verify the software on the target system. The development of the embedded systems from scratch using the traditional approach in designing is not effective today. Therefore, the experts presented the following higher-level methodologies for embedded systems hardware-software design that solve the problems of the traditional approach: co-design or parallel design, object-oriented design, platform-based design, and reuse methodology. Hardware-software design is considered as one of perspective approach to embedded systems design. The co-design technique has both advantages and disadvantages. On the one hand, it complicates the process of designing embedded systems. And on the other hand, it significantly improves the characteristics of the final product in compared to alternative design solutions. Object-oriented embedded system design has taken over the general methods used for software development. In this approach, software methods are used for the hardware description languages. This approach allows to take advantages of the object-oriented methodology. The platform-based approach allows significantly reduced design time by reusing pre-implemented and tested software hardware components of the system. Today, in the field of embedded system design, a reuse methodology based on the application of ready-made hardware and software components is very popular. Reusable software components include real-time operating systems, application programming interfaces, libraries, drivers, etc. The joint application of platform-based design and reuse methodology is possible on the basis of ready-made hardware-software platforms. The usage of such platforms contributes to shortening the design time for embedded systems and provides opportunities for use in other projects. So, the method of embedded system computer-aided design can be improved based on joint application of parallel and platform-based approaches, reuse methodology, remote and virtual engineering tools, such as recommendation systems and remote laboratories. There are many technologies for implementation of embedded systems hardware, which are placed on this diagram depending on their productivity, response time, and redundancy resources. They are microcontroller units, field programmable gate arrays, application-specific integrated circuits, programmable logic controllers, and others. It should be noted that microcontrollers occupy a special place as they have a balanced set of characteristics. The revolution of the platform-based approach to design was the beginning of new concept for embedded systems rapid development and prototyping. The application of ready-made hardware-software platforms simplifies the process of designing embedded systems through the usage of ready-made constructive solutions. In addition, specialized software supplied with them, higher-level programming languages, a large number of standard functions and libraries, simplifies the writing and debugging of the embedded system software. On this slide, you can see the most famous of them, such as Arduino, Raspberry Pi, and others. A sensor is a device that detects or measures a signal or stimulus. Actuator is a device that generates signal stimulus. Sensors are devices which acquire the information from the real world and convert physical properties to electrical signals. For example, temperature sensor, humidity sensor, presence detector sensors, and so on. The output signal is usually converted to human-readable display at the sensor location or transmitted over a network for reading or further processing. Actuators are the devices that convert an electrical signal to physical properties. Actuators require a control signal and a power source. Examples of actuators are different kinds of motors, LED-emitting diodes, and so on. An analog sensor generates an analog signal, whose level is a function of time. The change of such a signal is continuous. The signal constantly takes one of the many possible values. Thus, analog sensors are suitable for monitoring physical quantities that are constantly changing. Digital sensors generate output data that can be written as a sequence of digital values, often a binary signal, as a higher signal level or low. When transmitting information, digital sensors are more acceptable. Both digital and analog inputs of the microcontroller, for example, on the Arduino board, can be used to read values from digital sensors. Analog sensors must be connected via an analog to digital converter. So, sensors observe one or more properties of a physical object and convert the properties into data. Actuators can change these properties in response to the received information. So, they are able to influence both the environment and a certain object in it. The role of the actuator can be performed by a wide variety of devices, from speakers to electronic locks. The often used actuators for Arduino project are servo motors, relays, LED emitting diodes, different kinds of displays, and indicators. The Industrial Internet of Things is a concept in which various industrial devices, such as industrial sensors or equipment, are connected to the Internet. The wide range of IoT solutions is ideal for energy, transportation, industrial automation, and many other industries. In an industrial environment, many different protocols are used to control various devices, such as Modbus, Profibus, and others. One of the most widely used protocols is MQTT. To build industrial IoT systems, as well as to integrate existing equipment into cloud systems, special devices are used. They are web-programmed industrial IoT controllers, industrial IoT remote in-out modules, industrial IoT gateways, industrial IoT platforms, MQTT servers, meters of gas, temperature, humidity, and other parameters, and so on. On the slide, you can see the task for self-study. For one of proposed variants, you can prepare a brief introduction to the concept of IoT monitoring system, a use case diagram illustrating the capabilities of users of such a subsystem, and a description of the sensors and actuators you have chosen for the subsystem. So, embedded systems can be used in conjunction with various sensors and actuators to collect information and turn the collected or received information into actions. Embedded systems can use a range of technologies for connection with other devices or the Internet, for example, well-known Wi-Fi, Bluetooth, and others. The computer-aided design of embedded systems can be improved based on joint application of parallel and platform-based approaches, reuse methodology, remote and virtual engineering tools. The application of hardware-software platforms such as Arduino, Raspberry Pi, etc. simplifies and speeds up the design of embedded systems through the usage of ready-made constructive solutions. On this slide, you can see a list of recommended sources of information. Thank you for your attention.